Hi, this is question 20 of problem set 2, and so I'm gonna walk you guys through it. Yeah, so the first step the first thing that was stated was it's continuous, so that means that there's no holes, and right, yeah, that means that there's no holes, there's no isotopes, or like, yeah, or like, yeah, great. Anyways, and so the domain is for like the x values, like the x-axis. If we know it's all real values, we can use like the entire x-axis. So there's that. Moving on, so our first point that's given to us is g of 1, which is equal to 0. So we can go plot it here. So g of 1, and that's equal to 0. And then it says that g of x, so which is y, is less than 0 for every time that, like for every other number that when x isn't 1. So we know that this is 1. For every other number, the y number, like the y value, is going to be below the x-axis. So I don't know. I just kind of like to scribble it out. So there's that. And then moving on, the next point is g prime of x. So that's talking about slope is greater than 0. So that means it's increasing when x is here. So when it's like less than 1. So I'm gonna just kind of do this. This isn't an asymptote, but just kind of pointing it out. So that means it's increasing. Slope is increasing here. And then g of 1 is less than, or no, g prime of x is less than 1. So that's decreasing when the number is greater than 1. Hi, welcome back to part 2. So we know that the slope is increasing when it's like when it's less than 1. So something like that for now. And then this one, the slope is decreasing when the x value, when it's like a number greater than 1. So like that. Moving on, we know that g of 1 doesn't exist. So we can assume that's like a
G prime.
Oh, sorry, g prime doesn't exist. And so we can assume that's like a sharp turn, or there's like a hole, but since we know it's continuous, it can't be a hole, so sharp turn. And then g double prime is when it is less than 0. G double prime is for concavity, and so it's less than 0, so that's going to be like concave down when x is like less than -1. So I'm gonna just draw like a little marker for myself. So when x is less than -1, it's concave down, and it's also concave down when x is greater than 3. So like here, it's also concave down. So we can keep what we have here, like how I had it here, just because it's already concave down. And then here, g double prime is greater than, or is greater than 0 when between this interval of -1 to 3. So here we're having like the movement looks like this. And the reason why it's kind of like this is you can, it's like, to kind of like make better sense of this, you can kind of ignore these, and if you were to continue this, it would like look like that, and that's like a concave up. And the same thing over here, if you ignore this and you continue this thing, this is concave up, and so that's why it's drawn like this. It's just like half of the thing. Yeah, so I'm gonna get rid of that. And you can see that this is like showing that sharp turn. So that's showing that the g prime of 1 doesn't exist. So it's just that. And yeah, so this is what the graph looks like. Cheers.